Yeah, so the way this works is the recordings all go up to Scranton's server somewhere. And then every couple of days or once or twice a week, Nathaniel's got to go up there and move all the different telecon recordings up to YouTube. So that's why it doesn't always happen right away. Sometimes it takes a while. And once in a while we forget, like last week too. There was a lot of goings on at the beginning of the call. So my apologies for that. So good afternoon, everyone. Great to see everyone for the HamSCIence Telecon on today, Thursday, May 9th. I know a couple of people who won't be on the call today. Nathaniel's working on writing some grant applications so we can potentially deploy some more stations early next year, continue our monitoring efforts both on low frequency HF and the magnetometers. So it should be a pretty exciting program if the grants get approved.
Good.
But I guess there's a lot of work involved in getting those going. So that's what he's taking his time to do it. And Dr. West has some friends that are visiting in from out of town, so Mary Lou won't be with us today either. So we may have a relatively short meeting, I suppose. Is there anything anybody wants to bring up? I can make a couple of notes and we'll call it an agenda and make sure we cover a few things.
I ended up going down a rabbit hole this week, and I have a little presentation I can make about that if you're like. It's about mapping.
Sure, Ron, that'd be great. We definitely will have time for it. Is there anything else? Let me ask one question of Gareth since he's there in the office right now. The Friends of the Eclipse. Hello, are the Friends of the Eclipse conferences still going on?
Yeah, they are. We had one on Monday, and we're going to have another one, I think, on June 3rd. So the one we had on Monday, it was really, it was well attended, and we had more stuff to talk about than we had time. Yeah, so they're still going on, and I haven't posted an invite for the one for June 3rd yet, but that will be coming soon. But it's been really good, and it's been packed full of HamSCI results. So
okay. All right, great, because the last two, somehow I got my calendar messed up. The last couple that I logged in on, there was nobody there. So I obviously had the wrong dates. So and June 30th, I think I'll be traveling.
Okay, I'll make sure you're getting the invite correctly, and I'm doing that correctly from my end for you. So
okay, appreciate that.
Okay.
Yeah, it's always good to hear what the other groups and what other kind of research and whatnot is going on too. So okay.
One thing I wanted to add was people are curious, can we give some kind of sporadic E, whether it was there or not, in what regions of the US space when the eclipse was happening? And that's where the real, many people are interested. How can we say from HamSCI experiments whether the sporadic E is present or not?
Okay, that's a good question. That is a very interesting mode of propagation, especially for the folks who operate at the higher frequencies. From a ham radio term, from VHF and above, I guess you'd say, mostly is where we see sporadically. Though sometimes as low as even 10 meters, 28 megahertz, we'll see sporadically as well. Is anybody in the call familiar with? I don't know that we've done any research specifically in that area. It could have been done or been active long before I joined HamSCI too, a couple of years ago. But I think what I can do, Kuldeep, is in the next meeting invitation, I will mention that, and we'll see if the 1,200 or so people who get our meeting invitations have some information to add, and maybe they will join us. How does that sound?
Thank you.
Yes.
I know that one of the medium wave participants was also running FM recordings, and sporadic E sometimes shows up on FM broadcast as well. So I could certainly ask him if he had noticed anything.
No, that'd be great. So, yeah, and then if you could also forward him the invite for next week too, because obviously you don't have to belong to HamSCI to join in, listen in, or contribute to the call. So maybe something interesting to hear there too. So thanks, Nick. Let's see. So a couple of things. with Dr. West not here today, I'm not sure how deeply we want to delve into some of the lessons and some of her experiences that we've been talking about so far as analyzing the eclipse data. Is there anybody in particular that has anything to share from some of the work that she's been suggesting we do? If you want to call them homework assignments or whatnot. Is there anybody who's got any results or any graphs or any correlations that they might have done with the April 8th eclipse data? All right. One thing I would like to do, I would like to share a spreadsheet she sent me that though I missed last week's call, well, I was on the call, but I was otherwise occupied. Some of the work that she's done, and I kind of want to follow in her footsteps that you all might find interesting. So let me do a screen share here. There we go. Okay, too many things on the screen. And what else do I have to hide? That's it. Okay. So hopefully you all are seeing a black and white spreadsheet from my screen. So what Dr. West had been suggesting we do is take the University of Alabama website. And in fact, let me flip over to that too if I can. I'm not sure I can. Let me reshare. Share my desktop so I can bop around a little bit. So what I think she had suggested we do is we go to the University of Alabama central control system. I've had a login for some time, and go to the observations tab, use the filter, and I'll pick one of the stations that she was looking at in her spreadsheet. So this kind of all makes sense. KFS on the West Coast. Date wise, we only need the eclipse day. And to eclipse day. I'll just say the 9th just to grab a couple of days filter. And there's the two data sets. We'll look for the April 8th data. And there we have it. So it's an RX88, so we get multiple frequencies and lots of good stuff to look at. So let's take a look at her spreadsheet. So as she suggested, I took one station KFS, and this is her work. She's noted some common information she's using to build the spreadsheet as far as locations of WWV and CHU, some of the websites she used, because she said if you don't write it down, you'll forget it. She's made some notes about locations of the stations, and then she started getting into the data, the frequencies that those stations were recording. Made some note of the distances between station KFS and our time standards. The midpoint of the eclipse times, both in local and UTC. The amount of obscurance over that location, it looks like. And then she did some analysis of the graphs. She's got a number here for the symmetry. And she's trying to look at the mode splitting we've talked about a little bit, and some information about the directionality. So let's take a look at a couple of these graphs real quickly that have some good information on. There's a good one. 10 megahertz, obviously WWV, around 1800 if we zoom in on the eclipse time. So that's what you must have been observing, the amount of symmetry here, and also the number of modes, the number of lines contained in all that. And let's see, 10 megahertz, WWV, she's got a high value for symmetry. She opinion was a 0.9. She saw 3 modes and that sort of thing. So she collected a lot of this data for both KFS and Nathaniel Station there in Scranton, PA. And she's done some graphs, trying to look for correlations between these instances. For instance, here she's graphed distance on the x-axis, and then the amount of symmetry on y. And you can tell by this horizontal line, there's a slight, I would call it a negative correlation between those two. And then some of the hypotheses we discussed in the previous calls is symmetry inversely related to distance, barely. And I think that is a result of that very slight negative slope on that line. And some of the other hypotheses you got, some of the science questions that we originally went into this whole program about. And she's graphed again, distance versus the number of modes, symmetry versus local time, and symmetry versus midpoint obscuration. So there's not a lot of correlation we've seen so far, but I think it's been a good exercise to go through and understand some of the process she's been talking about, where we've got some data. We look at it 3 or 4 or 5 or 6 different ways and try to attempt some of the science questions. So if some of you have attempted this, hopefully your results maybe look similar. If you haven't tried it now yet, as I haven't, you've got a little bit of an opportunity to see how that worked. Okay, so I wanted to follow up with her lesson from last week. So any questions that I'm not sure I can answer them, but if there's any questions, maybe somebody else in the group can jump in too.
So I got a question. Carrie Case N1 URT. I didn't put my call sign down, but from up here to the state of Maine. So to do this, do we have to go to her site to do it?
Yeah, the place you're going to see this data is that University of Alabama site. That's the place that's collecting all the GRAPE 1 DRF data. The GRAPE 1s are the systems we deployed before October.
Okay,
You've
gotcha.
got a GRAPE 2, Carrie, is that right?
Yeah, I got a GRAPE 1, but it's it's the first one, but I'm not on that list, but I'm also running the GRAPE 2. I just started the GRAPE 2 up. But.
That's right. Yeah, back in April. Okay, so yeah, unfortunately, you're right. At the current time, the University of Alabama website is only collecting the GRAPE 1 DRF data. Yep. And also collecting magnetometer data. And the long-term plan is we've actually got people working on it, is to bring all that data into all the same format, have it all on that University of Alabama website, the one with the nice map, and then we can look at it all. But that's the place to go.
Yeah, eventually that'll happen. Takes a little time, don't it?
Well, we've got Kwong Nguyen working on it. He's working on his master's at Scranton, and I believe in computer science. And that's kind of been his project to get the GRAPE 2s out. And then right now he's working on some of the data conversions and plotting and all that sort of thing. I understand he's got a pretty long list of tasks I heard this morning. So. Oh
yeah. I tried to get my son involved. He's a professor over in out in Drake University, and he's a computer science guy, and trying to get him to get involved, but he's got different things. Different thing he wants to do. So
there's only so many hours in a day too, as I think we all know pretty well. So
that's right.
But yeah, that's the University of, and again, even if you don't have data up there, it's easy just to work through the login process, get a login, and then you can look at other people's observations. And eventually yours will be up there too. So
yeah. Yep. Thank you.
Good. Yeah. Thanks for hosting the GRAPE 2 as well, because you're the furthest point east. You're way out there in eastern Maine. So that was a good point for us.
Way out in the boondocks. I'm
nice
actually about 60 miles south of the Canadian border. Up there where the ski area up the Sugarloaf, near Sugarloaf. Yep.
Okay.
You don't have to. Do you have to worry about moose up there, or are they more in the interior of Maine?
Well, we used to have a lot of moose. We still do, but the ticks has been quite harsh up here in the last number of years. And according to the biologist and the warden service, and ticks had a lot to do with some of the, moose diminishing. But yeah, there's still moose up here. You still got to have your eyes out.
We used to see him in Vermont. So we had one that was camped out in the backyard all the time.
Oh, you did? Yeah.
Yeah, we were in Middlebury for a while. Yeah.
Oh yeah, I have a friend that was in Barry, lives in Barry. Yeah.
Yeah, I mean, here in Ohio, we worry about hitting a deer with a car, but hitting with a moose, that would be a very, very bad day, I imagine.
They're
Yeah,
faster than you think. That's for sure.
oh, yeah, yeah, yes, they are.
They only look dumb.
Don't judge a moose by its cover. Is that what you're saying, Ed?
Exactly right.
I got it. I got it.
Don't feed the moose. That's the other thing too. So.
No,
All right, good. So yeah, that's the place to get the data. So again, any other questions on that? Otherwise, we'll pick that up, I think, in 2 weeks, because next week we won't have a call because a lot of us will be traveling to Dayton or already there. So,
Hmm.
all right, good. All right, so well, let's see what Ron, you said you had some interesting things to present in the world of mapping and whatnot. So if you want to take control of the screen, you're more than welcome.
I turn my audio on back on. All right, let's see. I want to go over here and see if I can share my screen. Okay. Do you see the screen?
Sure
It said
do.
mapping paths of total eclipse and radio signal propagation. Okay, so this is kind of a little side project. I was started to do the analysis that Mary Lou had suggested, and I was in the process of doing that. I was trying to make little maps of where the propagation paths were, and so there was like one page that did that, and then I wanted to also see whether those relative to the eclipse path, and then there was another web page that did that. I was like, well, I really want to have everything together, so I decided I want to just see if I could write some code to do that. So that's what I'm going to talk about here today. So design goals then for this little project was I wanted to have a customizable tool that basically I would just input the location of the transmitting and receiving stations. I could then plot the path of the eclipse on a map of the United States, calculate the distances from the transmitting to the receiving station, mark sort of midpoints and possibly quarter points, which might be sort of interesting for 1-hop or 2-hop paths. I wanted to try to do this as accurately as possible, so using sort of a spheroidal model of the Earth, and save the data out to a file as needed. So that was what I wanted to do. So the first step was to get the data for the eclipse path. And so I was able to find a website that had the data for the April 8th eclipse. Basically, it had the center line and then also the northern and southern border, plus some other stuff. And so I was able to download that data and then write some code to import it into my code using MATLAB. So this was the data that was in that table. There was a bunch of stuff. The one I was most interested in is the one in the bottom right corner. That's the latitude versus longitude. So that's the eclipse path. And you can see it sort of has this sort of S shape. But there was some other stuff that was interesting in the file. I'll just mention it briefly. So this is the moon to sun ratio as a function of time. The path width in kilometers as a function of time. The center line duration as a function of time in minutes. This is the sun altitude and the sun azimuth, all as a function of time. So I thought that was interesting. I hadn't seen that plotted out before. Okay, so but basically this is the data I was looking for. Okay, so then as far as the coding goes, as I said, I've decided to use MATLAB because it's just something I'm familiar with. I needed something to help to do the mapping part, so I found there's a free toolbox called m_map. There's also a commercial part of MATLAB called Mapping Toolbox, but you have to buy it. And this supposedly is also compatible with Octave, which is a kind of a MATLAB clone of sorts. So I thought it might be useful for other folks as well. As far as the data for the mapping goes, there's some built into the mmap program. I use the coastal data from there. And then it suggested that you go out, there's a website called Natural Earth, which has a bunch of different things, including political boundaries. You can get like geographic data, all that kind of stuff. So I just downloaded the political boundary data. So I want to draw the states in, right? And then I decided to use a Mercator projection, just keep it simple. And then this WGS84 spheroid model, which apparently is the standard one that everybody uses. Okay, so this is what I came up with. This is the end product. So I picked just one station to start with. This is K8TRV, which happens to be fairly close to my house here in Michigan. You can see there, that's the station plotted in here in Michigan and near Dexter. It's just close to Ann Arbor. And then I plotted WWV over here in Fort Collins and CHU over here in Ottawa. And then here you can see the eclipse path, right? Dashed line is the center line. And then it plots out the geodesics, which correspond to the probable path of a radio wave signal, and marks the center points with a circle, a dot, and then the quarter and three-quarter wave points with little cross or plus signs. And then it also calculates the distance and marks that on the map. So that's what I wanted it to do. So just to validate this, I compared this to an existing map that I found from NASA for the eclipse path. That seems to line up pretty well, I think. So that gave me some confidence that was working. And then also I checked against the geodesics here against sort of some other pages, the GPS visualizer, I think Mary Lou had mentioned in a previous call, and that seemed also to be on track. So I have some reasonable confidence that the code was working. So that was great. And then I just have a few other examples I'll show off briefly. This is a station from Florida, and it kind of shows you two paths crossing the eclipse line. And so that was nice. And then this one here, you can see the midpoint's almost in the total eclipse path. And here's another one from Massachusetts, which again, both of these paths cross the eclipse path. And not all these stations necessarily have data from both sites. I think only the first one had data from both sites, but just kind of a proof of principle. And so that seems to be working. And then I decided, well, if I can do one station, I can do multiple stations. So I wrote some code to plot all 3 stations at once, for example. And this will actually do an arbitrary number of stations. I just plotted these 3 up for an example. And then just to show that it's a little bit customizable, I have some flags set up in the code so I can change things around. So for example, well, suppose I want to go from a solid line to a dashed line, I can do that. Suppose I only want to plot the midpoints, I can do that. It's got a fair number of options you can set. So I was thinking as if I were to plot more and more, I might want to not have as much information on the plot. So that's that. As a little aside, I was kind of curious to know what's the difference between the if you plot assuming a spherical Earth and a spheroidal Earth. And the answer is not much, as you might expect. It's pretty close to a sphere. But I was just curious to see. So this is actually the latitude versus longitude for this path to the station in Florida from WWV. And so the solid line is the spherical model and the dashed line is the spheroidal model. And you can see they're almost coincident. And just to sort of drive that point home, this is a plot of the difference between the latitude for the spherical and the spheroidal. For the latitude here and the longitude here. And you can see here, this is on the order of thousandths of a degree in latitude and longitude. So I thought that was interesting. Okay, so then just to conclude, I feel like the code has achieved its design goals from what I set out to do and some possible future improvements. I thought it would be nice to be able to have a little contour map which shows maximum obscuration beyond just where the total eclipse path is. I think that would be a nice feature to have. I'm not quite sure how to do that, how to get that data or to calculate it, but I think that would be nice. And then I think there could be some refinements of the actual map in terms of the coastal border and the maybe adding in some topographical coloring to show maybe where the mountain ranges are. So anyway, that's my little presentation. So I hope that was interesting or useful. I think it'd be a nice tool to be able to plot these things up and kind of see better what's going on. So that's it. Any questions?
Not so much question, just simply, yeah, I've been copying and pasting this. It's, there's some really interesting ideas there because I've been, sort of looking at, the data that's being submitted to me, and yeah, just visualizing this whole idea of where where stations are relative to receivers and so forth is quite, sort of, it just, it allows you to get a feel for, like what is going on relative to the path of the eclipse. And, that's pretty important to sort of just, feel that you have some grounding in reality, rather than just throwing piles of numbers around. So thanks very much for it.
Yeah, certainly we're willing to share this out. Again, it is written in MATLAB, and or you might be able to port it into Octave if you're familiar with that code. It's not too different. So yeah, I just got tired of the putting numbers into websites myself. And this is nice because it really it accurately calculates these things all out. So it'll actually calculate the coordinates for all these points. And if you need or want that information, it's there, and you can write it out to a file and put it into some sort of format that you might be able to use elsewhere. Okay, well then that's all. Thanks a lot.
Yeah, thanks, Ron. Very good.
Yeah, that's pretty slick, Ron. I could see especially some of Nathaniel's students who are writing papers and giving presentations for the first time that they could focus on the more RF side of things, what they've gleaned out of the data, but then use your maps and put the whole thing together. That really makes it come alive for the audience. So
It does.
all right, wonderful. Okay, great. Let's see what else was going on. Oh, one other announcement I wanted to make. It's been a few months since he's been on the call, but there was a high school student by the name of Adarsh. His call sign was KN6 Victor India Sierra. He was on our call last summer, early fall, and then he got busy with school. The other thing he got busy with was helping me with the scoring at the Solar Eclipse QSO party. Adarsh and his father were at the workshop back in April here in Cleveland. And we were talking about what he wanted to do so far as where he wanted to go to school and what he wanted to study. And his interest is physics. And I found out a few days ago he's been accepted at UC Berkeley in their physics program there. So that's, I think, quite an accomplishment. He's got I think, a bright future ahead of him. I took a look at UC Berkeley and some of the different areas of research and things that they're doing there. And if somebody's interested in physics, he's got plenty of opportunities. So if hopefully, Adarsh, someday you're watching some of these videos and you'll see that the group is very happy to see that you got in for the great school. So you never know. You work with people when they're young, and 20 years from now, I may see or hear or read and see papers by somebody, and we can all say we knew them when. So that's a good thing. All right. I think that's about it from me. Is there anything anybody else wants to bring up or any other questions? Again, I just want to remind everyone we're not going to have a call next week. I'll put out a reminder probably on Wednesday evening. And then we'll meet again on, well, it won't be the 16th, the 23rd, I suppose it'll be. So hopefully I'll be back in town and recovered from the Dayton Hamvention. So.
Hey, Gary.
Yeah, sure.
Is there more logs coming in? Have you got any more?
Yeah, I was gonna ask.
Oh, that's a good point. Let me take a quick run over to that website real quick. Let me do a screen share and we can go see ourselves. Let's see. Let's see. Let's go to our favorite website, CQP, section X. Let's take a look. The log robot. Logs received 485 logs.
That's good.
And there are a little over, I think about 120 from the Gladstone Signal Spotting Challenge. So if you think in 2017, I think there were like 566 logs. So we've got 485 plus 120. We're a little over 600. So
that's good.
Yeah, got a lot of, and I think we're still waiting on W2NAF. So Nathaniel's going to have to get, he's going to have to ask for special dispensation to turn in his log late. So.
Yeah, there's a deadline, you know.
we'll have to vote him on or off the island. You guys, we could all vote in 2 weeks or something. But anyhow, so yeah, if somebody forgot and still has a log, obviously get it to me and we'll put it in there. I don't want to miss anybody.
Yeah.
But technically the log window's closed and the robot should be refusing them. So that's that. So.
Gary,
right.
just one thing I was thinking about here is that we're getting requests still, for presentations, and obviously, sort of rolling into 2025, I guess, right? But maybe coming out of Dayton, we might want to think about sort of like what a standard deck should look like, for presentations in the fall and early next year. Obviously, as we start to get more data, as to what that deck's going to look like, so we're all on the same page. People are doing presentations, that type of thing. So, not too early to think about that.
No, that's a good point, Ed. And one of the things that helps that along, I know Nathaniel's giving a talk at Dayton at the Antenna Forum, but
Yep.
it is entitled Early Results from the QSO Parties and whatnot. And I think I leaned heavily on last year's talk, either a contest university or the same forum, to create our standardized deck. So
Yep.
Once we get that off of them, we can definitely lean on that.
Yep.
Yeah, I think he's looking for, he's been looking for input from, like various aspects of HamSci. And because I've been working on something for him myself. And yeah, that would be, by the sound of it, a really good starting point, so that it's fairly universal as to all the things that HamSci is doing, rather than just the solar eclipse QSO party. So yeah, that, we'll have to see what that looks like, I guess.
That's true. The other thing I'll mention too is Steve Serwin was doing the exact same thing, was feeding him information for the Antenna Forum presentation. And Steve has really got a really great presentation. He asked me if I wanted to show it today and get some opinions from anybody, and I'd be glad to go through it, but I I don't understand all of it. There's some mathematical and some analysis concepts in there that I frankly don't understand. So I feel kind of funny presenting something I can't explain. But I think Steve would be definitely the better person to do that. I know he couldn't make the call today, so if it's okay with you all, I think I'd rather let Steve do the presentation, because he could work through those things where I would be lost. So it won't help. What was that old saying? I'm not a scientist, but I used to play one on Zoom, and I don't want to get into that. So that's not me.
Yeah.
So
I could throw in what I just sent to Nathaniel, actually, if you like, Gary, and that doesn't involve much math.
no, Nick, yeah, go right ahead. I'm sure everybody would like to see it.
Okay, it'll take me a moment to set up sharing the screen.
Yeah, that's fine.
Okay, let's see.
So we started the call talking about sporadic E. Nick's interests are at the opposite end of the spectrum, more in the much longer wavelengths, hundreds of meters.
No. Sorry, this is I only just thought of this, so I'm just having to. Maybe I'll start with sharing the screen, and then you'll watch me thrash around. Okay.
We've all been there, so.
Yeah. Okay, I think that's the one we want, and this is starting the slideshow from the beginning. Okay, can you see that?
Yes, we can.
Okay. Yeah, okay, well, it's, the introduction is just that we had about a couple of dozen amateurs and SWLs recording the entire broadcast band during the 8th of April eclipse. And we've now gathered together all the recorded data and processed it with carrier sleuth, which allows us visual impressions of receiving conditions on every broadcast band channel throughout the period. And we can also get signal strength data, as well out of that. Okay, so let's see. Oh yeah, it does work. Good. Okay. We had one of the participants was Scott Newell and 5TNL in Fort Smith, Alabama, or Arkansas, I should say. And he recorded actually a big swath of data, not just the eclipse. So there's a lot of comparative information there as well. And this is going to be just taking a quick look at just one of the channels during the solar eclipse, which is a 1530 kilohertz broadcasters on that channel. And as you can see, it's a real mess. There are, there's a number, several carriers. This is, this is nothing like audio at all. And, what we're looking at is a swath of, let's say, about 50 hertz. So the carriers are, sort of separated by a few hertz each. And the strongest one are this one here and this one here, which turned out to be KGVT, Harlingen, Texas, which is down near the Mexican border, and then WCKY in Cincinnati, Ohio, and I'm sure you know where that is. And this is not just carriers. The recorded data, you could hear, Spanish sports talk, like dominating the channel. And it came out of nowhere, as the eclipse was moving by. And then it faded down, and there were a bunch of English language commercials come up, and a identification from WCKY in Cincinnati, Ohio, on right there on the hour. And say we can derive the actual signal strength data out of like that display that I showed you. And you can see, the blue line was Harlingen, Texas, rising up to like a good solid, about 40 or 50 dB over the background level, and then dropping back down again. As it drops, the signal level comes up from Cincinnati, and I can see, just presenting this, that I really need to throw another map in so that you can visualize this, just as Ron was talking about a few minutes ago. And there is a map later on, but we should probably have one here, open for comments on this one. And just as a comparison, as I say, Scott had recorded the whole band the day before as well. And the green and purple lines are, like what the channel normally looks like at that time of day in the middle of the afternoon. And you can see in the faded background there is what the signal strengths look like during the course of the eclipse itself. So like what happened during the eclipse is decidedly out of the ordinary. And repeat this, that you're now looking at the peak signal strength on each of those stations coming up. KGBT was 1846 UT, WCKY at 1908 UT, separated by a few minutes. And the analysis, sort of little tiny bit of analysis I did, this is all descriptive up till now, is, well, how did this correspond with the actual passage of the eclipse? And this is where we finally get to a map. You can see that, like I've got written down the times of the peak obscuration down here in Harlingen, Texas here. Whoops, sorry about that. Got to stop. There we go. I'm too ambitious with the mouse. And, the eclipse is now moving past that and towards Arkansas, where, it's about 20 minutes later is the maximum eclipse, and then finally into Cincinnati, which is another 20 minutes after that. But what you can see with those white vertical sort of oblique lines is that the actual peak occurred not at the halfway point on the paths, but actually closer to, well, in KGBT's case, it actually occurred fairly close to the receiver in Fort Smith, Arkansas. And then as Cincinnati faded up, well, it actually peaked as the eclipse was approaching Cincinnati, so nowhere near the halfway points. So, this is where we get into the so what does this all tell us? And at the moment, I can't tell you because I'm not a scientist. But it does appear that at least for signals that are parallel to the path of the eclipse, close to it, that the eclipse totality needs to have actually moved on a fair bit past the center point before the peak signal strength occurs. So, like whatever's happening in the ionosphere in terms of damping down or, sort of removing the absorptive qualities of the D region, seems to sort of take a little while to really take effect. But, if we're looking at an actual skip, then you're dealing with, you would assume the halfway point, that the absorption at various points along that path is going to be quite different as the eclipse moves along. And this is where like the simulators are going to have to tell us what the heck is going on, because like if you just switched off the D layer at when the eclipse was, say, at down there close to the Mexican border, and then switched it back on again as the eclipse passed Arkansas, you would presumably get a peak pretty much, just at the halfway point, where you're getting, a single hop up into the E layer. But, as I say, I'm in the position here of just sort of fairly high level, just low level speculation, shall we say. So anyway, that's the extent of what I sent off to Nathaniel. So I'd be happy to have any comments, and I will try and get back to letting you have my screen back, which should be here somewhere. My gosh, I hate this. It's not telling me how I can do this. Shoot, I'm gonna have to minimize. Oh, there it is. Zoom share. Does that give it back to you? Nope, don't think it has yet. Pause share, quit share. It's not. This is ridiculous.
Hey, Nick.
There we go. Yeah.
Yeah, I got a really dumb question. Okay, on one of the earlier slides, where he tracked the day before signal strengths.
Yes.
For the two stations. I mean, that's a pretty good shout. Okay, Fort Smith. I mean, it looks like it's equidistant between the two stations, but I mean, I guess what we're saying in daylight the day before, he was still able to receive the stations, correct?
No, actually, what I did there was I actually simply went back to the exact frequencies. I say that's a 50 hertz spread there.
Okay.
And you can zero in to 0.1 hertz with that software. So I just went back to the exact location. Now, I think what's happening with the signal from KGBT is that there might be some residual ground wave, coming up from Texas, because like the signal level's down about minus 110 dB, which is, I mean, that's 50 dB below the peak strength on the eclipse day. So it's a long way down, but it actually seemed to be a real signal. As far as the Cincinnati signal, it wasn't there at all. Like I think what you're looking at is the noise level, rather than anything real. But as I say, the Texas signal looked like there might have been a small residual ground wave signal. But again, I'm in speculation mode, but it's a good question.
Okay. Thank you.
Very nice, Nick. That was an interesting presentation. It makes you think, yeah, you're right. You look at one station receiving two others and you can draw some conclusions. But since you had 25 stations potentially listening, it'd be interesting to see, as you know, over the long term, to see if all those results lined up similarly. So, but
no, and I think as I mentioned at the workshop, I mean the medium wave band covers like a 3 to 1 frequency range, and what's relevant at 1530 kilohertz, and I did specify that that particular, this is only relevant for that particular frequency, maybe, is that it probably isn't like that at all at 1000 kilohertz or 600 kilohertz. And those are some of the things that one needs to look at, because like that too can feed back into like whoever's doing the simulation of what the ionosphere looked like at that point, and say, well, is this what you'd expect? but you know, like, no, I would not expect that at even 1,000 kilohertz. But this is only just like a first like little dig into the data. You know, like just so much there, and being able, you know, like what Mary Lou was talking about earlier, it's trying to zero in on like what it is that you want to sort of dig out in the way of information, and try to form some hypothesis, because there's just so many things there that you could ask about. So anyway, that's just zeroing in on one thing, and whether or not it's relevant overall, I couldn't tell you because I haven't zeroed in on anything else yet.
Oh, very nice. Thank you, Nick, for presenting that. I'm glad we saw that. Interesting. Okay, it's 4:45. Is there anything else anybody wants to bring up? Otherwise, I'm going to go back to getting ready for Hamvention, and I just got a box of stuff from Nathaniel. I got all our posters and our flyers and our banners and all the stuff we use in Orlando. Just made it back to my house today, so I'll be
Lucky
getting
you.
that. Yeah, I'll be putting all that together. So and Greg
Work's
offered
just
to help
begun.
too. So yeah,
Work's just begun, Gary.
That's right.
yeah, there you go. So work, that's a 4-letter word for me. I've been retired 6 years now, so trying to figure what that word means.
That is.
I got a question though, Mackenzie. I know your classes start next week. What's your schedule like on Thursdays next over the summer?
I will be available for the meeting still at 4. I don't have any classes on Thursdays. It's just Monday, Wednesday, Friday. So I'll be
Oh,
here.
okay.
All right.
All right, that's good news. Good. We'll see you every weekend, hopefully. So I know it's also summer, it's vacation season. A lot of people are coming and going, so that's the way it goes. Especially in the northern hemisphere, we got to make hay while the weather is good.
Mm.
Okay, if that's it, we'll wrap it up. I'll end the recording and say thanks everyone for participating, for joining. We'll be back together in 2 weeks, I hope, God willing, and all that kind of good stuff. And when we don't have another Carrington event, we'll be all fine. So that's
Thank
it.
you, Gary.
73 off.
I've got
73.
my tube
Thanks, 73.
equipment. I'll survive.
There you go. That's right. If you've got tubes, you're good. 73 off.
73s.
73.